Okay, I'm cranking them out today. Now going to be working on phase shift, which is kind of the end of everything here, putting it all together. All right. So we're going to have a combination of our graphs being moved up and down and left and right. So let's start off with, this is 7.8, number 3. We want to graph y equals 4 sine of 2x minus pi. All right, so this is a sine curve. I know what a basic sine curve looks like, and I'm going to be using, setting the argument, the entire inside, 2x minus pi equal to 0, and 2x minus pi equal to 2 pi. That's the standard technique. Notice I don't have a plus or minus out here, so this thing is not being moved up or down. Solving this for x, I move the pi over, and then I divide by 2. So pi over 2 is one of my points, and the other one, I move the pi over, I get 3 pi, divide by 2, I get 3 halves pi. Okay, so now, go to my graph. It's going to start out at pi over 2, which is right here, somewhere. And then 3 pi over 2 is somewhere over here. Now I need the halfway point. And I need the quarter points. So what I can do to get the halfway point is add these two together and divide by 2. So if I take this and add this, I'm going to get pi over 2 plus 3 pi over 2. That's 4 pi over 2. That's just 2 pi. So this is going to be 2 pi, but then divided by 2. So just pi. Now if I want to go from here to here halfway, I'm going to take, I'll do this one by hand, pi over 2 plus pi, and I'm going to be dividing by 2. So that's going to be pi over 2 plus 2 pi over 2, common denominator, over 2. This is 3 pi over 2 over 2 over 1, and flip, you get 3 pi over 4. So 3 pi over 4. All right, and then to get this halfway, do the same thing. Take pi plus 3 pi over 2, add those two together, and then divide by 2. So this is the same as 2 pi over 2. So I'll just do that now, 2 pi over 2. Add those together, you get 5 pi over 2 over 1, which is flipping, that's 5 pi over 4. All right, there we go. We've got our important points. Now keep in mind this is a sine function. So the starting point and the ending point and the middle point should be x-intercepts. Now I just need to figure out here if I'm going up or if I'm going down. So I'm going to plug 3 pi over 2 into this. So y equals 4 sine of 2 times 3 pi over 4, that's 2x, minus pi. Okay, so where am I here? This is cancel, cancel, it's 3 pi over 2. So I have 4 sine of 3 pi over 2 minus pi, but I'm going to get a common denominator. So 2 pi over 2, that's the same as pi, but now I can subtract these. This right here is just pi over 2. And of course, sine of pi over 2, straight up, sine is y. So you get 1, 4 times 1, that gives you 4. So here, we're at 4. And then that means down here, we're at negative 4. I won't draw it, and then draw a graph like this. There you go. So it's a sine function. It's been moved over to the right by pi over 2. Oh, they want us to find everything. Hold on. All right, so amplitude is 4. Okay, and then to get the period, we take omega right here, and 2 pi over omega. 2 pi over omega, sorry, over 2, that's going to be pi. And then you want the phase shift. Phase shift. Okay, the phase shift is going to be, now let's see if they give you a formula for phase shift. No vertical shift. There we go. It's, okay, so it's this number right here, pi, over omega, which was 2. So your phase shift is pi over 2. I don't like that. I never memorize that formula. I always just look at the graph and I can tell, look, this is a sine curve. It's been moved to the right by pi over 2. So our phase shift is pi over 2. But what you can do is just take this right here and divide it by that, and you get your phase shift. Now, if this had been a plus, right, if that had been a plus, then you would take negative pi over 2, and that would give you a shift to the left. All right, let's do another one. I'm starting to actually get tired of this. Number 5. Y equals 2 cosine of 3x plus pi over 2. This is a cosine function. I know what those look like, right? They go like this. So I'm trying to figure out where those points are. So I'm going to take the argument, set it equal to 0, take the argument, set it equal to 2 pi. Standard technique here. X equals negative pi over 2, and then x equals negative pi over 6 when I divide both sides by 3. Here, 3x equals 2 pi minus pi over 2. So I'm going to switch this common denominator and make this 4 pi over 2. So I get 3x equals 3 pi over 2 when I put these together. And then divide by 3. You get, oh, the 3's cancel when you divide by 3, so you just get pi over 2. Okay. Now, I know this is a cosine function. Got some weird values here. My y-axis. I have negative pi over 6. And then I have pi over 2. I have important values here. I have this one, this one. I've got halfway between them, and then quarter marks, and I don't know where those are yet. Let's find the one that's halfway in between first. Halfway in between, I add these two together. Negative pi over 6 plus pi over 2, then divide by 2. Get a common denominator here of 6, so I'm going to multiply the top and bottom of this by 3. Okay. Then when I add this, this is negative 1 pi plus 3 pi's, that's 2 pi over 6 over 2 over 1, and when I reciprocate this, the 2's will cancel, you'll just get pi over 6. So this right here is pi over 6. And it just so happens now that if you take these two, add them together and divide by 2, when you add these two together, you get 0. So this red one is actually at 0. I wasn't sure, so I had to check it. There's 0. And then I need to find this one, which, again, if we're counting, you can kind of see we went over by pi over 6, pi over 6. So this would be another pi over 6. That's 2 pi over 6. That's pi over 3. And then this would be 3 pi over 6, which is pi over 2. So you could get this by adding and dividing by 2, but just kind of took a little shortcut there. And now this is a cosine function. It's a cosine function. Since it's cosine, I know that I have x-intercepts at the first quarter mark and the 3/4 mark. And then it's either 2 up here or 2 down here. So let me pick a test point. How about this one? And let's just figure out what happens. 2 cosine of 3 times negative pi over 6, and then plus pi over 2. All right, this right here, that's just negative pi over 2. Plus pi over 2, that's 0. Cosine of 0 is 1 times 2. So we get, at this point, we go up, wait a minute, right here. Here we go up 2, we're at 2. And that means at the other end, right here, we're at 2. And that means that at pi over 6, we're down here at negative 2. And so our graph looks like this. There it is. So let's now get all the information they wanted. The amplitude is 2, the absolute value of this. The period is 2 pi over omega, so 2 pi over omega, which is 3. And then the phase shift, we're going to take this right here, but see if it's a minus, we just take the number, but if it's a plus, you take the opposite. So it's going to be negative pi over 2 over omega, which is 3. And this is going to be negative pi over 6. So remember, that's 3 over 1, you reciprocate. So that means we have a phase shift of this of a cosine function to the left by pi over 6. And you can see it. If imagine this and move it to the right, and you would have your standard cosine. So what we did is we moved that to the left by pi over 6. All right, we're making progress. These take a while. Number 7, negative 3 sine of 2x plus pi over 2. It's a sine function. I know what sine functions look like. I've got a negative out there. It's going to do something. I set the argument equal to 0. I set the argument equal to 2 pi. Why? Because it's a sine function. I always do that for sine and cosine. Solve this. Move this to this side. 2x equals negative pi over 2. Divide both sides by 2, you get negative pi over 4. Here, 2x equals 2 pi minus pi over 2. I'll make a common denominator here, so change that to a 1. Now multiply top and bottom by 2, so that becomes a 4 pi over 2. So I get 2x equals, subtract, you get 3 pi over 2. Okay, and then if I divide by 2, I get 3 pi over 4. 3/4 pi. So it looks like this. Starting here at negative pi over 4, ending over here at 3 pi over 4. And this midway point, and then I have quarter point and 3/4 point. This is a sine curve, so I know it's got to go here, here, and here. Those are my x-intercepts. Oh, I never found this one. So I'm going to take these two, add them together. So negative pi over 4 plus 3 pi over 4 is 2 pi over 4. So I've got 2 pi over 4, but then divide that by 2 over 1. We're just going to get pi over 4 there. Okay? If you flip it, the 2's will cancel and you just get pi over 4. So now I've got to go midway here and here. Is that going to be 0 again? That's kind of boring. Yeah, if I add those two together, I get 0 and take half of that, it's still 0. So that's my quarter point. And so let's see, if this goes by pi over 4, this would be 2 pi over 4, which is pi over 2 pi over 4 is pi over 2. And then this would be 3 pi over 4. So yeah, that looks like that's what's happening, going by pi over 4 each time. Okay. All right, so this looks a little off because I'm going to kind of change it a little bit. I'm going to just move that y-axis here. That'll be there. Okay, so now what I need to know is, does it go like that or does it go like that? So I can pick a test point. I'm going to pick 0. 0 should be easy to plug in here. Negative 3 sine of, let's see, 0 here kills it, so I just have pi over 2. Sine of pi over 2 is 1, but then times negative 3, so negative 3. So it's 0, I'm down here at negative 3. And that means over here at pi over 2, I should be up here at positive 3. So I should go down, go up, like that, like this. All right. The amplitude of this sine curve is the absolute value of the negative 3, which is 3. The period is 2 pi over omega, which is 2, so this is just pi. And then the phase shift is this number. Now, it's actually the opposite. If it's positive, it's negative. If it's negative, it's positive. So pi over 2 over this number 2, which is pi over 4. Now, it's saying here, oh, you know what? I forgot to put the negative. Oops, negative. negative, because it's positive, it has to be negative here. So negative pi over 4. So you can see that this is a standard sine curve that would have done something like this, but we moved it to the left, pi over 4. All right, number 11. Y equals 3 cosine of pi x minus 2 plus 5. Yay, we get to move something up 5 at the end. All right, so it's a cosine function. I know I'm going to set the argument equals 0 and 2 pi. So pi x minus 2 equals 0. Pi x minus 2 equals 2 pi. And now solving this, pi x equals 2, which means x equals 2 over pi. That's weird. We've never seen that before. But that's what it is. And then we set it here. We get pi x, adding 2 to both sides, equals 2 pi plus 2. And if we divide both by pi, I'm going to get this divided by pi is 2, plus this divided by pi is 2 over pi. All right, so we got to make sure we get these in the right place on the number line here. 2 over pi, and then this is 2 more than 2 over pi. So 2 over pi is smaller than 2 plus 2 over pi. Now, we could get the halfway point, because we need these. We need this, this, and this. This is a cosine function, so I know I have x-intercepts here and here, but I need to know what these values are. So we could add these two together and then divide by 2, or we could just think about it, like how far is it from here to here? Well, the only difference between these is that we've added 2. So halfway should be 1 plus 2 over pi. And then this one would be half of that. So that should be 1/2 plus 2 over pi. And then this one should be 3/2 plus 2 over pi. Okay, now that might be tough to figure out. So let me do it mechanically. How would we find this one? Well, we take 2 over pi plus 2 over pi. Add these two together, we get 2 over 4 pi. So all we're doing is we're taking 2 over pi plus 2 over pi. They have the same denominator. That's 4 of them. 2 and 2 is 4. Then we take this whole thing and we divide it by 2, which is the same as taking this and multiplying it by 1/2, right? The reciprocal, oops, that's a 1. Flip that like that. And then when you distribute that through, what happens? Half of 2 is 1. And then when you do half here, it cancels. You just get plus 2 over pi. So 1 plus 2 over pi is this one. Now, I'll do one more. Let's get this one. To get that one, I have to take these two, add them together, and divide by 2. So I'd be taking 1 plus 2 over pi, plus this one, 2 plus 2 over pi, and then dividing the whole thing by 2, which is 1 plus 2 is 3, plus 2 over pi plus 2 over pi is going to be 4 over pi. And then I'm going to be dividing by 2, which is the same as multiplying by 1/2. And then I distribute the half through, 3/2, half through here. Again, the 4 and the 2 reduce, you get that. So this is where that is where this comes from right there. This one I'll let you do yourself. Okay, that's kind of weird, huh? All right, so we've got all those points. Now, this is a cosine function, and I'm ignoring the plus 5. Got a 3 out here. I need to test the point to figure out if I've got 2 up top or 2 on the bottom. So if I plug in 2 over pi, I should figure this out. So y will be equal to 3 cosine of pi times x, which is 2 over pi minus 2. And then I'm not going to do the plus 5 right now. So notice that if I do that, the pi's cancel. 2 minus 2 is 0. Cosine of 0 is 1. Times 3 is 3. So I know that at this point right here that I was testing, I should be up at 3. And that means that directly across at the end, I'm up at 3, and that means down here I'm at -3. So this is what it would look like. But I still need to shift it up 5. So that means I take this point up 5. So here's 8. So that goes up to 8. The one that was 0 goes up to 5. This one that was at -3 goes up to 2. That should be up further. 2. This one should go up to 5, and this one should go up to 8. So when I draw like this, there's my graph. Taking care of all that. Amplitude here is 3. Period is 2 pi over this. 2 pi over pi is 2, which makes sense because between here and here was 2. And then my phase shift is going to be this, since it's negative, I'm going to use positive, 2 over, and then omega pi. So it looks like I moved this cosine function to the right by 2 over pi, which you can see here. This is the cosine function. I moved it to the right by 2 over pi. Interesting problem right there. I like that one. That was 11. 17. Write the equation of a sine function that has an amplitude of 3, a period of 3 pi, and a phase shift of -1/3. All right, so here's what I know. First of all, it has an amplitude of 3. So it could be 3 or -3 here. I'm going to use 3. It's a sine function. It's got a period of 3 over pi. So if it has a period of 3 over pi, remember, period equals 2 pi over omega. And if we solve this, period here is 3 pi. We solve this for omega. We get 3 pi omega equals 2 pi. And that means omega is, divide both sides by 3 pi, we get 2/3. So that means I need a 2/3 here, x, and then I need to use my phase shift somehow, right? So let me do this. I'm going to say minus, I forget what they use. I'm going to put beta here. I know that's not right, but let's just say it's minus something. What I know is that if this is minus, this is plus. When I take beta and divide it by 2/3, I need to get my phase shift of -1/3. So how can I undo this? Well, I'm trying to solve for beta here. So what I can do is, and this is a little tricky, first realize that this is really 3 beta over 2. So just like flip the fraction up like this, equals -1/3. And then at this point, multiply both sides by 2/3. And then you'll get your 2's and 3's cancel. You get beta is -2/9. Like that. And so if I put in here -2/9, it'll change that to a plus. So let's just double check this. If I take this number, since it's positive, I take the negative of it. If I take -2/9 and divide it by this number, 2/3, I better get -1/3. So flip this fraction up, I get 3 over 2. And let's see what happens. 2's cancel, 3 goes in 3 once, 3 goes in 9 3 times, you get -1/3, so that works. So this is it. You could also have a negative out there, but that function will work. All right, how are we doing here? 2 o'clock, got a little bit more time. I really want to get these last ones done because these last ones are really good problems. Okay. Let's look at number 19. Okay, we've got y equals 2 tangent of 4x minus pi. We're trying to graph this. All right, so I need to go back to my memory bank here. I'm graphing a tangent function. Tangent functions, I'm looking at negative pi over 2 and pi over 2. Those are where my vertical asymptotes occur. In the middle at 0, I get that x-intercept. So that's what the basic picture looks like, except I'm going to need to take this argument, 4x minus pi, set it equal to negative pi over 2, and then 4x minus pi, and set that equal to positive pi over 2. Moving the pi to the other side, you get 4x equals pi over 2. I'll let you do the arithmetic there. You're taking pi and subtracting pi over 2. And then here, divide by 4, you get x is pi over 8. Okay, here, add pi to both sides. You should get 3 pi over 2. And then dividing both sides by 4, you should get 3 pi over 8. All right, graph. Those are both positive numbers. So here's pi over 8. Here's 3 pi over 8. These are where my vertical asymptotes occur. I know that halfway, which would be add these two together and divide by 2. So if I add this to this, I get 4 pi over 8. Then divide by 2. So 4 pi over 8, divide that by 2 over 1. And when you do the math on this, this is really pi over 2. And then you're going to flip, and so you should get, wait a minute, pi over 2? You should get pi over 4. Yeah. There we go. I know at pi over 4 I have an x-intercept. Now it's just a question of, does it do this? Does it do this? Well, to figure that out, I look at the number out in front. It's a positive number, so I know it's going to go like that, like a normal tangent. And it's 2, which means it's stretched out. We're not really too concerned about stretches, though. So I'm just going to kind of draw it in here best I can, like that. There we go. Now I think the next problem is probably like a really important problem, because this is a lot like what you would see on a test, this problem right here. We've got 21. Y equals 3 cosecant of 2x minus pi over 4. All right, this is a cosecant function. To draw a cosecant function, I actually need to draw the sine function. So I'm going to be looking at 3 sine of 2x minus pi over 4. There's no vertical shift up or down here. So since there's no vertical shift, I don't have to worry about it at the end. I'm going to draw this. To draw this, I have to set the inside, the argument, equal to 0 and 2 pi. I'm doing that because it's a sine function. Okay, solving for x here, you should get pi over 8. I'm not going to show the work. Here, 2x equals, let's see, that's going to be 8 pi over 4 plus, so 7 pi over 4. No, 9 pi over 4. 9 pi over 4. So what I'm doing here is I'm adding pi over 4 to both sides, killing that off, and then I'm rewriting this as 4 and 8. Yeah, that would give me 9 pi over 4. Then divide through, I get 9 pi over 8. All right, I'm going to draw that over here. Sine curve starts at pi over 8, which is a positive number, so it's to the right, and then 9 pi over 8. Halfway. Well, add these two together. That should give you 10 pi over 8, right? Add those two together, you get 10 pi over 8. Then divide that by 2 over 1. That's going to be 5 pi over 4 over 2 over 1. And then flip, you should get 5 pi over 8. And then you could do, I'm trusting you could do these others. This should be 3 pi over 8. This should be 7 pi over 8. So I'm letting you get those two on your own. I got you that one. You do the rest. So now, this is a sine function, so I know beginning, middle, and end I have x-intercepts. And I now need to figure out if it goes like up and down or down up. So I would plug in, I would test this point in here. So 3 sine of 2 times 3 pi over 8 minus pi over 4. All All right, this is 3 sine of, let's see, that cancels, and that's a 4. So this is 3 pi over 4 minus pi over 4. 3 pi over 4 minus pi over 4 is 2 pi over 4. And 2 pi over 4 is the same as pi over 2. And sine of pi over 2 is 1, and 1 times 3 is 3. So I know that up here at 3, I have my graph, and then that means down here, -3, I have this graph, or that point. And now, remember, this is just to get us set up. So I do this. I draw vertical asymptotes at all my x-intercepts. And then this one's going to go like that. This one's going to go like that. This one's going to go like that. And this one's going to go like that. So that's it. You could do another period, but that's the graph of 3 cosecant of 2x minus pi over 4. And you can see just by looking at this, there's a phase shift on this. But I'm not going to get those. Let's just leave those alone. And that's it. I'm going to offer as a bonus to anyone who watches this video that's in my face-to-face class this semester here, spring 2018. Actually, I'll offer this to anyone who's in my face-to-face class, period, that watches this ever. If you want to do number 22, page 595, then I will take that as a bonus, but I'm not going to mention it. And then number 23, I'm going to do number 23. And then I'll be done. 23 is a cotangent problem. And I think we've only done one cotangent. Okay, so 23, got negative cotangent of 2x plus pi over 2. All right, this is a cotangent function. The reason I wanted to do this one is to remind you with cotangent, we have 2 important points, 0 and pi, and then halfway at pi over 2, that's where we had our x-intercept, and then it went like the reverse of tangent. So it's 0 and pi that we set the argument equal to here. 2x plus pi over 2 equals 0, and 2x plus pi over 2 equals pi, not 2 pi. And then moving along here, 2x equals negative pi over 2, and then x equals negative pi over 4. Here, 2x equals, let's see, I'm subtracting, so this is going to be pi over 2. Pi, take away pi over 2 is pi over 2, and then you get pi over 4, dividing both sides by 2. So now, you've got negative pi over 4, that's an interesting point, and pi over 4, and that's where your 2 verticals are going to occur. You know that halfway in between, which you don't have to think about here because it's 0, you know you're going to have your cotangent function. And so I should draw it like this. However, there's a negative 1 out in front. And what that does is that flips it around and it makes it look more like a tangent function. Now it's not because these important points are different, but it looks kind of at the end of the day like a tangent function. So there it is. There's your graph. And that does it for this section. And that means I am good up through 8.4. Awesome.